Hi, I'm following along with Paul McWhorter's Raspberry Pi Pico W lessons. We're on number 6, and it's about if statements in MicroPython. This was a review for me, but I figure Paul gives us homework. Probably ought to do it. So um, we'll get to the code and wiring. So I'm using my Raspberry Pi cam from the other lessons Paul's doing to display my uh, wiring setup here. It's just basic wiring with LEDs and 3 resistors and current limiting resistors, and got ground in uh, 3.3, so I got that, and then got one line going pin 28 to the center of the potentiometer. So got that set up here. I figured first thing we'll do is show you what my high and low readings are, since we can't get all the way down to 0. Let's go ahead and run this. And all the way up. I can get all the way up. 5535. I can only get down to about 192 low. 192 is where I'm going to put it. All right. We stop that one. So now I'm on to the homework. So first thing we had to do, we're from machine, we're getting the pins since we have to do LEDs, and we have to get ADC since we're doing the potentiometer. And we're setting up our pins. I did a little different color scheme because I think of these numbers as like a heating system, where if it's cold out, low numbers, low temperature, you're going to turn on the red for heat. Green means it's good to go, and once it gets high, it's going to be blue because we want to have some air conditioning cooling this off. So that's the way I got it set up. So I have the R for the low, G for medium, and B for high on these pins. Pot pin, I'm calling pot ADC. I took all Paul's great math and put it into a function for us, where we're figuring out our slope, and then we're solving for the Y on this one. And the Y is just our scaled reading, and we're returning it. So I got called them, wanted variables for the 2 set points Paul gave us. So it was 79 and 95 is what he gave us for homework. And now got the while true, so we can turn off our LEDs when we're done, so they don't stay on. This part here, first 3 lines, we're reading our ADC, then we're scaling it, and going from, all we're doing is putting our pot read in our input range and our output range. He wanted 0 to 100 on the output range, and all the great math up there in that function gives us returns a floating point, and I just wanted to round it to even numbers just to make it easier to display on the screen. And that's called our scaled reading. We're printing it out. Then we're going to turn on our LEDs depending on which ones are there. So basically we're taking our scale readings on this, and if it's less than the low set point, meaning that we're in low and we want to have some heat on, so the red comes on. I got G there still. I had started off with a G, but that should be an R. So this on and off is the same as saying lead dot value equals 1, and this would be lead dot value equals 0. So just a different way of doing it. You can do it either way, works best. And then we got this one here where we have to check 2 things. We have to check if the scale reading is higher than our low set point, and our scaled reading is lower than our high set point, meaning that we're in the middle. And if we're middle, we're turning the middle LED on, which is the green one. And then for the third if statement, we're seeing if the scaled reading is high, is greater than high. So if it is, that means we're turning the blue one on, get some AC going in here. Then we're just sleeping and just doing that again every second. So let's see if I can get it running. So we're on 0, so it's freezing in here. So we're having to get our heat going. And as we turn it up, once we get to 79, which is a little warm for me, when we get up to 80, we go into the green section. So we don't have any heat and no air conditioning. As we keep turning it up, once we get up to 95, better than 95, we have to get the AC cranked up. So trying to show you something here that this was really a thermostat. You wouldn't want to have a thermostat that turned on the AC and then turned it off real quick and turned it on real quick. We're jumping between 95 and 96 down here. So you have to have a different way of coding that so that you can account for that so you don't get this. It's called short cycling. You wouldn't want your heater coming on just for that little bit of time. It'd probably burn out everything in there after a while. So we'll go ahead and stop that. And I got a third code up here showing how we can put a differential in there so that it doesn't have that problem. So this is the same code all the way through here. Function, hot and heat, and I got more reasonable figures in here. So in my house, I like to keep my heat coming on at 70, and I like to have my air conditioning coming on when it gets hotter than 85. So I figured I'd use my numbers in there. And we'll just put a differential of 3, and I'll show you how that works. So this first 3 lines of code are doing the same thing, getting the raw reading and getting it scaled, and we're printing it out. So now comes the difference. It's the same thing. We're turning LEDs on and off, but we're going to have to keep track of where we are. This is called a state machine. So we can tell which LED is on by calling this function rlead.value and then putting nothing in the parentheses. What that's going to do is return an on or off value, or a 0 or a 1, or a true or false. So remember our if statements, they're trying to find out if what we're doing is true or false. So and their and, if the red is on, that's true, and then we can check the second part of this. And this way you're only going to check the one that you're only interested in, the one that really matters. We're going to check that just to see what's going on with that. So we can start off with this one. So we've changed our logic a little bit in here. So now if we got our red on, if our heat is on, and we're checking if our scaled reading has got above our low set point, and then we're adding that differential to it. So if we had 70 plus 3, we're looking for our scale reading to be above 73 before we go ahead and do this. So we've changed the logic. Before we were checking to see if we were still in the green or whatever, but now we want to see if we want to change it. And if we do want to change it, then what we're going to do is we're going to go down here and we're going to turn the green on. That means we've satisfied we're warm enough that we can turn our green LED on, which means the red goes off and of course the blue's off because we don't want AC and heat on. So neither one of them's on, so the green is just saying that the system is good to go. So that's what that one does. So if this does turn this on and the green lead comes on, we're going to go down here and we're going to run this one too, because the red lead was on at the beginning of this, but we turned the green lead on. But now we're checking the green lead, whether this turned it on or it's been on from last time through the loop. It's going to check it. But when it's in the green section, we have to check two things. We got to see if it's the temperature has got out of the green low or out of the green high. And if it's done either one, we got to do something. And the third option is no, we're still good, and it just doesn't do anything. So, if we're in the green and our scaled reading is lower than our low set point, that means it's below 70. That means that we gotta turn our heat back on. Our red LEDs coming back on, and then it checks that. Of course, it's going to also check this one too. But if this one's true, then this one's not going to be true. So it won't do that. I mean, it'll check it, but it won't come out true. And then, of course, it's going to also go down here. So let's say that for some reason we were in the green, and then it goes to red. It's just going to, then this one won't do anything, and it's going to go back up top. And the red's going to be true, so then it's going to check and see if it's satisfied. But let's say if we're green and this part of it is true, that it got hotter than the high set point. That means we're going to turn our blue LED on, turn the AC on, and then it's going to go down to this next one. And it's going to check and see, okay, well, the blue lead's on, but we're going to see if it's below this high set point minus differential. So the only way this came on was because it was above 85 here. And then this says, okay, well, the blue's on, but I got to check this part. So if it was above 85, it's going to check this side, and it's going to say, my 85 minus our differential minus 3, 82 degrees. So we're going to see if this is below 82, if this is less than 82. We already know that just a microsecond ago that this was above 85, so it's not going to be 82. So this part's not going to, even though it runs next to, part of it's true, the rest of it's not true, so it's just going to keep going. So next time through, like I said, we're already on blue. So blue, it's going to keep checking. Hopefully your AC is working, and your, I actually got this wrong. The blue lead should be on. Oh no, that's right. Only if it's satisfied, the green comes on. That's right. I got confused. So all we're going to do is do that, and we'll see it. And I can try to show you that you have that differential in there when, so you won't get that short cycling where it's blinking back and forth between two states. It's going to be in one state for time it takes for the differential to get satisfied. So let's see. Go ahead and run it. And we're at 96, so our AC is on. So remember, I think, what did we put on our temperature up here? 70 and 85. So let's go ahead down. So we need to get to, before it goes back to green, we got to get to 85 minus 3. So we got to get below 82. So we should have to go down to 81. Yep, 81, it turned green. Now if I turn it up a little bit, 82, 83, 84, it's still green. It's not going to come on until we're at 86, above 85. Now we're at 86, and it's on. And let's check and see if the other way works. So we'll go way down, and we're at 9. So we're going to warm up to close to 70. But remember, our heat's on, so we're going to go and get our 70 plus 3. So we got to go to above 73 before we're going to go off. Now, your differential on your regular home thermostats are probably 1 degree or maybe 2 degrees. 3 degrees would be a lot. But with this potentiometer, it was hard to just get 1 degree in there. Slow. There we go. 70. We were at 70. We're still on. Still heating because we want to warm that house up until we get to 74. And now, okay, it's satisfied. So the heat's off, but maybe it's cold outside and it's slowly getting cooler, slowly getting cooler. But your heat's actually not going to come back on until we get below 70. So it has to get to 69. 69, the heat came back on. Anyhow, that's the way that's the way thermostats would work, and that's the way I would code a thermostat, make it work right. Like you say, we don't want short cycling to ruin our equipment. Anyhow, that's my lesson for homework for this week, and thank Paul for all the great lessons, and I keep enjoying seeing what other people are posting for their videos too. So keep it up, guys. You're doing a great job. Thanks. Have a great day, everybody.